So I start exactly from the program which I had written previously, the program previous to this. User will input a number, the program needs to check whether the number is prime. Now if you remember what was the logic was I have firstly scanned the number within n, I have checked from starting from 2, I is from 2. So I have started checking from 2 and I have gone up to n by 2. I initially said that I need to go up to n minus 1. Say 43 is a number, I need to check from 2 to 42 whether any number, 43 is divisible by any of these numbers. However, checking up to half of that, that is 43 by 2, 21 in its integer format, checking up to 21 is enough. So every time I will check that whether n% I is equal to 0. If it is equal to 0, it gets divisible by a number. So I know it is a non-prime number now. I initialize flag equal to 1. I just change the flag to 1 and break. But the flag was initialized to 0. So if it does not enter the if block, it means it will go out of while normally with flag equal to 0. But if it enters the if block, only then flag will become 1 and it will break out. Which means if the number is non-prime, if n% I ever becomes equal to 0, flag will be 1. Otherwise, it will go out of the while loop with flag equal to 0. So if flag equal to 0, I will check that over here. Printf, the number is a prime number. Otherwise, it's a non-prime number. Now, why have I taken up this program again? Because using this program, I want to now tell you something different. Like, there is while, which is a loop format. There is another format of writing a loop, which is for. Instead of while, you can write for. That is something within for, like something you write within while. You remember? Now, what is the difference between while and if? While is a loop. It keeps on moving until and unless this condition is false, while keeps on iterating one after the other. If it goes only once. If it is true, it enters. If it is false, it does not enter. It does not go many a times. It is this while which keeps on moving. So while is a loop, if is a block. For is a loop, exactly like while. What is its purpose? Exactly the same purpose as that of while, no difference. So like you do for a while, exactly in the same way you write for. So instead of writing while over here, I could have used for over here. Then what's the purpose? Why not while, why for? Because I see one thing, that see, to write a while, to write any while loop, you need an initialization. Like see over here, you initialized I to 2. That was the initialization that you needed. I was initialized to 2 before starting a loop. Before starting any loop, the condition on which you will be checking the condition of the loop, that variable needs to be initialized. Like over here, I is initialized to 2. So I less than equal to n by 2 is the condition checking on that variable. It needs an initialization I to 2. It needs a condition checking which is done within while. And also before you come back to this while, you need some constant iterating variable to change. Like everywhere, I am needing a variable like while. I am needing a variable, this bracket is disturbing. Anyway, you need this while, this I plus plus every time is needed to go back to the while. So before going back to the while, you are needing a variable which is your main iterating variable, and that to change. Like while I less than equal to n by 2, you have started with I equal to 2, you have checked the condition I less than equal to n by 2, and before going back to the loop the second time, you have done I plus plus. So these three things are always needed. You remember this once more. I equal to 2, initialization before the loop. I less than equal to n by 2, condition checking before entering the loop. I plus plus every time once the loop is over, before going back to the loop, this condition, this changing of the iterating variable. So these three things are needed. For loop gives you a way to incorporate these three things in one place. That is, you don't need to initialize I equal to 2 over here, you simply declare. For an understanding purpose, this for is very interesting, it helps you to understand easily. I equal to 2, you initialize over here, for I equal to 2, the initialization. The initialization you do within this for. Condition checking, that also you do within this for. You see, you have initialized I to 2. Instead of doing that, that initialization you do within for. The condition checking, I less than equal to n by 2, that condition checking you do over here. And another last thing that you do, that is I plus plus. That also you don't need to do within the loop, you can do it over here. I plus plus. What this has helped is, it has helped the readability of the program. Somebody else seeing your program, it is easy for him or her to understand the purpose of the program or understand the purpose of this loop. You have initialized, you have started with I equal to 2. Every time at the end of it you have incremented I, and you have continued this until I is less than equal to n by 2. Now what happens is, when you start the first time before entering this loop, this first condition is checked, and it is always written like this. The format is like this, you check out. For, firstly you initiate, initialization, then semicolon, this comma is wrongly typed. For, you start with an initialization, next condition checking, and then iteration. This is the condition always of writing, this is a way of writing for always. So what happens is, before it enters this for loop for the first time, see this, before it enters the for loop for the first time, what happens is, first time, before entering first time, this initialization happens. This does not happen any other time. Say when it goes back, enters the for loop and comes back to the start of for loop again, it does not go for this initialization. This initialization happens only once. That is, first time when it is entering the for loop, this initialization happens. This initialization is done. If it enters the for loop the first time, comes back to the second time initialization will never happen. What will happen? What will happen is, it will do from the second time onwards, it will do iteration. Now how it does is, first time it does the initialization, first thing initialization, then it does condition checking. True, if it is true, condition is true, enters the loop, executes this loop once, goes to the start, does the iteration, again does the condition checking. Condition checking is true, enters the loop the second time. I again start from the beginning. First time in the loop, first time it enters the for. First time it encounters this for. First thing it does is initialization. Second thing it does is condition checking. If condition checking is true, it enters the for loop, executes the for loop once, goes to the start of for loop, iteration, does not do initialization only once, does the iteration. The first time iteration was not done, first time initialization was done. From the second time onwards only iteration will be done. So iteration done. Then condition checking. True or false? Suppose true, enters the loop for the second time. Executes the loop the second time, goes to the start of the loop. So before it enters the third time, iteration. Then condition checking. If condition checking is true, only then enters for loop, otherwise does not enter. Executes the loop the third time, goes back, again iteration, then condition checking. Condition checking true, enters the loop the next time, and so on it continues. Say the nth time, iteration, it goes to the start of for loop, nth time. Iteration is done, condition checking is done, but suppose the condition checking is false, it will go out of the loop. So you understand what it does? It does the initialization only once, the first time. The first time the initialization is done. The iteration is not done the first time. Initialization done the first time. Condition checking done the first time. Enters the loop first time. After this loop goes to the start of for loop. Second time when it enters, firstly it does iteration, which it did not do the first time. Then condition checking again. If condition checking is true, enters the for loop. Again goes to the start of for loop after for loop is over. Iteration done. Then again condition checking. Then enters the for loop and so on. This is how a for loop is executed. I get rid of this part and write this program using for loop. How you can do that? You see what? Very simple. If you use a for loop, this part I will also get rid of. This part also I will get rid of. Later. Firstly, let me write. See, the initialization was I equal to 2, which I had done over here, I. So you start I equal to 2, semicolon. Your initialization is done. In while your condition checking was I less than equal to n by 2. Now you are using this for loop. So your condition checking I less than equal to n by 2 remains as it is. What is your iteration? Your iteration is I plus plus. So this I plus plus you can simply delete from here. Instead what you can do? You can do the I plus plus here. So that is what you wanted. In while what you did? You initialized I equal to 2. So that is what you are doing, initialization first time. Every time before entering you are checking I less than equal to n by 2. That is being done here also. Every time it is checking starting from the first time. But it does not do the I plus plus first time. It enters with I equal to 2. It enters with the initialization I equal to 2. So first time it is done n%2. But next time when it comes back to the loop, you remember I plus plus will be done first. So I becomes 3, which you are doing over here. That is not needed. When it comes to the start of the for loop, it firstly does this iteration thing and then checks over here. So this program will run absolutely fine. You can get rid of this portion which I had used to explain to you. Get rid of this bracket which I had used to explain to you. Now if you run this program will again run absolutely smoothly. Alter, enter. 45 is a non-prime number. Alter, enter. 47, it's a prime number, not divisible by anything apart from 1 and 47 itself, is a prime number. Check any other number, say 99, definitely a non-prime number. However, if you write 97, definitely a prime number, and so on. So this program with for absolutely runs smoothly. However, to explain to you for, I will take a simpler program now. If you want to, you can pause this video, take a bit of rest and come back. However, I will continue a little more, saying if you remember, I started while loop explaining you loop by the sum program. What sum program? I wanted sum equal to 1 plus 2 plus 3 plus 4 plus 5 plus 6 and so on, plus plus up to plus n. That is what was the first program of while loop I had written. So in this case I can say the program was user will enter n. The program should output this sum equal to 1 plus 2 plus 3 and so on up to n. So I think you understand this. This is what the program is. So this program was written using while loop. Now I want to write this same program using for loop. How to write? Hash include stdio.h should remain. Hash include, I have not yet explained to you the reason of writing hash include stdio.h, kunio.h, main. All these things will be explained in due time as I go through this entire series of lectures. So this is main, and at the you have to close this bracket. Remember, don't forget this clear screen and get ch at the end. Now, how to write this program? You remember what I can do for that is I need a I variable which I need to initialize to 1. So this I variable will be incremented every time in the loop, and that I will be added to the sum every time in the loop. So what is your initialization? I equal to 1. What is your incrementation part? I plus plus. And every time what do you check? I is less than equal to n. Is not it so? So your initialization is I equal to 1. Every time in your increment is I plus plus. And every time what you are going to do at the for the condition checking is you will check whether I has reached the value of n. So cannot you write this program very easily? You need the variable I, no doubt, you need the variable n, no doubt, and you need the variable sum, no doubt. So you can tell the user printf enter the value of n. That is definitely needed. Put a colon, space, and then okay. So you need to scan that. Scanf %d ampersand n. You scan that. Now you need to go for a for loop. For, see what is your initialization? Your initialization is I equal to 1. So cannot you start by writing for I equal to 1? What is your condition checking? How long will you keep on adding I1 to this n, to this sum, until and unless I becomes equal to n? So your condition checking is for I equal to 1, then I less than equal to n. And every time at the end of the loop, what do you need to do? I plus plus. Remember, this I plus plus does not happen the first time. So first time when it enters the for loop, it enters with the initialization I equal to 1, checking whether it is less than equal to n, it enters the for loop. But when it comes back to the for loop the second time, it does not do this I equal to 1. This is done only once. It does the I plus plus. So I becomes 2 and then checks 2 less than equal to n. Enters the loop the second time, comes back, I plus plus happens. That is I becomes 3 and 3 less than equal to n is checked. So every time in the loop, what do you need to do? You just need to do one thing. Sum is equal to sum plus I, nothing more. That part is enough. Or you can write it as what? Sum plus equal to I, if you remember. And you don't need this bracket anymore because no other thing is written in needed in this program. Just every time in the loop, this I has to be added to sum. But the sum needs an initialization also. So you can initialize sum equal to 0 over here, or two initializations are possible also. Here you can put a comma and write sum equal to 0. Remember, not a semicolon. A semicolon means your initialization is over. You go to the condition checking now. But a comma means your initialization continues. So you initialize two things. For I equal to 1, sum equal to 0. And here you check the condition I less than equal to n and then I plus plus. Remember, initialization happens only the first time. So the first time I becomes 1, sum becomes 0. It checks whether I is less than equal to n. Then it enters the loop. It adds I to sum. Goes to the start of the loop, does I plus plus. I becomes 2. And again checks I less than equal to n or not. And so on. This continues. So I think you understand this. We can end our for loop over here and say I have got the sum. You can simply write printf the sum is %d, and this %d has to be replaced by what? By sum. So printf the sum is %d, sum, and get ch is enough. So now you can run this program and see whether it runs fine. It will definitely run fine. You don't need the sum equal to 0 twice. You have done it once over here, that is enough. So let me run the program now. Oh, sorry. As usual, I have forgot to comment out this portion where I just only explained the purpose of the program. This is not a part of the program. Okay, let me run it now. Enter the value of n, 5. 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10, 10 plus 5, 15. Run smoothly. Again run with say 9, 45. 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10, 10 plus 5, 15, plus 6, 21, plus 7, 28, plus 8, 36, plus 9, 45. So the program runs absolutely smoothly. My request to all listeners, all learners are that please go back and write all the programs that you have seen till now, all the lessons that you have seen till now. Please change the while and write those same programs with for. Each and every program that you have written till now or I have explained till now, please replace the while and try to do it with for. Okay, thank you.